Hey guys, in this video we're going to talk about the 2024 FRQ for Calc AB. This is question number 3. And the purpose of this one, guys, is to be able to fine-tune your focus on what you're looking at. Now, this is differential equation. Now, as soon as I see this here, I'm thinking already, okay, they're going to ask me to find the particular solution based on the initial condition, separate the variables. And now I see this, I love to see this because this is an easy question. I have to draw, based on the slope field, the graph of the slope field, and that's not very hard. So let's get into it. It says the depth of the seawater at a location can be modeled by the function h that satisfies the differential equation. It's given to us. Okay, so this is the rate. H of t is measured in feet and t is measured in hours after noon. Okay, so t equals 0 is at noon. It is known that h of 0 is 4. All right. A portion of the slope field for the differential equation is provided. Sketch the solution curve. All right. So this question is only worth 1 point, but it's a very easy point. And you see here it has to pass through this. And all you got to do is make sure that the graph passes through this point. So you just make sure you go through here. And where does it go here? Probably here. And just make sure you have to go all the way through. And that's it. And that's your point. Okay, it doesn't ask us to justify anything, and we're done. Okay, so very, very simple. All right, question for letter B. For the time between 0 and 5, it can be shown that h of t is greater than 1. Okay, so it's a parameter they give us. All right. Find the value of t for the time between 0 and 5 at which h has a critical point. That should come off, ding, 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 a bell in your head. How do you find a critical point? Hopefully you can remember derivative, set it equal to 0. Okay. Determine whether the critical point corresponds to a relative minimum, a maximum, or neither a relative minimum or maximum of the depth of the seawater. And look at this, justify your answer. Okay, so hopefully, guys, when you see here critical point, you're going to take the derivative and set it equal to 0. So what does that mean? dh dt, we're going to set it equal to 0. And they give us dh dt's right here. Okay. So let me go ahead and write dh dt is equal to 1/2 times h minus 1 times cosine of t over 2. All right, so if you look here, we're going to set this guy equal to 0, okay? And when we do that, this h of 1 is not going to have any effect because they tell us that h of t has to be greater than 1. Okay, so this can never be equal to 0. And so what we're going to be left with is just cosine of t, this guy, cosine of t over 2 is going to be equal to 0. So we want to know, okay, how to solve this, all right? And so you're going to do cosine inverse. So t over 2 equals cosine inverse of 0. So where on the unit circle is cosine 0? All right, so remember, now if you have to draw it out for yourself, so this is 1 comma 0, okay? This is 0 comma 1, this is negative 1 comma 0, and this is 0 comma negative 1, okay? Remember, your x is your cosine, your y is your sine. So where is cosine 0? Here and here. So at pi over 2 and at 3 pi over 2. All right. Now, so we're going to go t over 2 equals pi over 2. All right. And then the other one is t over 2 is equal to 3 pi over 2. All right. And then, so if we solve this one, the one on the left, we're going to get t is equal to pi. All right. And if we solve this one, we're going to get t is equal to 6 over 2. We're going to get 3 pi. All right. But if you look at our parameter here, it's the time has to be between 0 and 5. So 3 pi is way too much. It's way out of the limit, so we cannot use 3 pi. So the only one, our critical point, is going to be at t equals pi. So what do we do when we find a critical point? Number line. All right, here's our pi. All right, so here's our function, h of t. All right, and over here, I guess we can say that's 5. We can say that's 0. All right, but what have I done? Nothing really, guys. All I've done is take the derivative, set it equal to 0. Now remember, when they give you these questions, because you only have, what is it, an hour, and you have 4 questions, so what are you gonna have, 25 minutes? So you're not going to be given something extraordinarily hard, okay? But you are going to be required to know these simple, trig functions, okay? But look at, all I did is set the derivative equal to 0, and then cosine inverse of 0. I drew myself my little graph here, all right? And then I just went step by step, all right? So now I got to pick a value between here, okay? Now this can be tricky because you're dealing with pi, but just cut it in half if you need to, right? What's between 0 and pi? Well, it'll be pi over 2. All right, so what happens when I plug in pi over 2? Now this guy's going to be positive here, okay, because this is h of t has to be greater than 1. But what happens when this guy becomes, for example, pi over 2? So let's say I have cosine of pi over 2. Okay, well, that becomes cosine of, when you this becomes what, pi over 4. All right, and if you don't know it, just keep, change, flip. Okay, and you're gonna get nervous. All right, you're gonna get nervous during the test, and that's okay. Just guide yourself back, talk yourself through it. Okay, don't panic. Okay, just, all right, critical point. Okay, derivative, set it equal to 0. Okay, how do I do this? All right, pick a value. Well, let me just cut it in half. Keep, change, flip. You'd be surprised how simple mistakes you can make just because of the test, the anxiety of the test. But don't worry. All right, so what's cosine of pi over 4? That's going to be a positive value, okay, right here. So that's going to be a positive. Okay, and then you do the same thing here. What's, after pi? We can do 3 pi over 2. Okay, and then just pick any value, 3 pi over 2 divided by 2. Well, that becomes cosine of 3 pi over 4. 3 pi over 4. And cosine of 3 pi over 4, let's say, I don't know, let's just say for some reason you don't know, okay? All right, just draw yourself. Okay, this is positive, positive. This is negative, positive. Okay, this is negative, negative. Okay, this is positive, negative. Okay, so you ask yourself, where's 3 pi over 4? And you know that this is 1 pi over 4 and 3 pi over 4 is over here. And where's cosine? Right here. It's negative. Okay, there you go. So this guy's going to be negative. So over here, you go up, and we're going to go down. So therefore, we're going to have a max. Okay. So nothing too difficult, guys. Draw yourself out what you need. Okay. Don't be afraid to do that. Now here, the last thing says justify your answer. Okay. Now, just by drawing this, you're not going to get the point. So what you have to say is for dH/dt, it's positive between 0 and pi, and dH/dt is negative for the time between pi and 5. And then you can say, therefore, we have a relative max. Okay. There you go. And that's it. Our relative max at t equals pi. Okay. And that's it, guys. That's it. I know it can seem kind of daunting sometimes, but believe me, it's doable. Okay. All right. That's probably the hardest one, guys. Okay, so the first part was worth 1 point. This one was worth, I believe it was 3 points. Okay, but what did I do? Derivative, set it equal to 0, and just be careful with your math. Draw yourself out your, your values here. I did my plus plus, minus plus. Okay, go over your basic derivatives. Nothing too difficult. Now the meat. Let's say you get the part B wrong. This part here is worth 5 points. So let's say you get the first one, that's 1. And you get all of this, that's 6. That's 6 out of 9. You're on your way to at least a 3 or a 4. So remember, when you see differential equation, you gotta focus. You gotta remember they're gonna ask you to separate the variables, find the particular solution based on the initial condition. All right, so here we go. All right, so use the separation of variables to find h of t. All right, for this differential equation. So hopefully you guys have done enough of these. So we're gonna separate these and take the antiderivative. So I'm gonna divide. So I'm gonna have dh over h minus 1 equals 1/2 cosine of t over 2. Now guys, you're gonna see, for some reason, you always see a lot of ln's over here on these with separation of variables. I've seen that. If you look at the test over the years, you see a lot of this, okay? So don't be afraid of it, expect it. Okay, so if you remember, what is the derivative of dh over h minus 1 or dh over h? That is ln of the absolute value of h minus 1. All right. Over here, this is a constant. I'm just gonna pull it out. The antiderivative of cosine, you guys know that, it's sine of t over 2, okay? Now remember, you have something on the inside, okay? You're gonna get something on the inside all the time. They'll give you something, okay? The derivative of t over 2 is 1/2. And we're gonna divide, right? We're gonna divide by 1/2, and that's the same thing as multiplying by 2, okay? So remember, when we're taking the antiderivative, we're dividing by the chain rule, I guess you can call it. And when we divide by 1/2, it's like multiplying by 2. So what happens? The 1/2 and the 2 simplify each other out. And then we have plus our constant c. And you can see how it just cancels out. So we're left with ln of h minus 1 is equal to the sine of t over 2 plus c. Now let's say you're confused and you say, man, I don't know if I got this right. Well, just take the derivative of this guy. Take the derivative of this and you should get this guy right here. That's it. All right, it shouldn't be too difficult, guys. But remember, this question is done by hand. And if you notice, it's pretty straightforward because they understand they can't give you something that's very long and lengthy because your time is limited. But you do have to understand your basic derivatives, your basic antiderivatives, right? Sine, cosine, tangent, secant squared, all those basic ones that your teacher showed you. All right, so now, okay, from here, we have to find our initial condition. Now, I think for the most part, it's a lot easier just to go ahead and from here, just plug in your value here. So h of 0 is equal to 4, all right? So we're going to have ln of 4 minus 1 absolute value is equal to the sine of 0 over 2 plus c. All right, 4 minus 1 is 3. Ln absolute value, it doesn't matter because it's going to be positive, so it's ln of 3. Sine of 0 is 0, so c is equal to ln of 3. Nice, okay. Was that hard? No, not at all. Not at all. And let's say you're doing this and you are, getting something lengthy and long, go back and just redo it again, okay? It shouldn't take you that long, okay? Now here, why did I take away the absolute value? Because I know based on the condition that they gave me that h of 1 is going to be positive. So if you remember here, h of t, is going to be greater than 1. So this is always going to be positive. So I'm going to remove the absolute value. And now from here, what do? Well, we're going to raise it to the power of e. Here we go. The whole thing. So what's going to happen? The e and the ln simplify out. So we're going to be left with h minus 1. Now remember, now be careful with this, okay? We're going to get e to the sine of t over 2 plus ln of 3. Now I'm just going to do this the long way. H minus 1 equals to e times the sine of t over 2 times e to the ln of 3. So remember, e and ln simplify out. You're going to have h minus 1 is going to equal to 3 times the sine of, I forgot my e, I'm sorry. 3 times e to the sine of t over 2. And we're going to, when we bring our 1 over, we're going to get 1 plus 3 times e to the sine of t over 2. And that's it. That's it. Was that very difficult? Was that very hard? Was that undoable? No, it wasn't, guys. You guys can do it. So this is question number 3. So anytime they give you a differential equation, guys, focus. This is what they're gonna ask you, okay? So if there's one thing when you see a differential equation to focus on, is learn how to separate the variables, and always look for this ln, because it's gonna be there. All right, guys. Hopefully that helps you out. I know I have other videos with past questions on there. Go ahead and check those out, and you start to see the pattern. And believe me, you guys can do this. It's not very hard. All right, guys, I'll see you guys on the next one.